Hello. So previously we've seen that the two transistors connected in series generated the NAND function. And I mentioned that if we'd had them in parallel, we would have created the NOR function. So we're just going to have a quick look at that. And here is a circuit to do that. So here are our two transistors. They're connected in parallel so that current flowing through this resistor here has a choice of path to go either through this transistor, or both. As the same in the previous circuits, we have a control for each of the transistors. And we can see the voltages that we can apply at the input, the currents flowing into the base of the transistor, the current which flows into each of the collectors, and also the combined current here. Currently with the inputs at 0 volts, we have no current flowing, so no voltage is being dropped across this resistor here, so our output is at 5 volts. So let's change the controls and see what happens. We'll start with this one here, which is controlling this transistor. If we increase the voltage, input voltage, to above the threshold to switch the transistor on, we get current flowing into the base, the larger current flowing into the collector, and that current is causing a voltage drop across this resistor here, so our output drops to 0. If we do the same with the other transistor, get a similar kind of behaviour. If we go above the threshold, start to see current flowing into the base of the transistor. Again, current flowing into the collector, which is coming through this resistor here. So a voltage drop across this resistor, reducing our output to 0. If both control inputs are high, so if we increase this one to above the threshold, then we get current going into the base of both transistors. Because the transistors are comparable, they're exactly the same type, the current flowing through here splits roughly 50-50 between the two, because the two transistors are comparable. You can't get any more current flowing through here, because with our 1000 ohm resistor here, our power supply is limited to providing 5 milliamps. So you get the 5 milliamps through here, and then roughly 2.5 milliamps each side. And we can increase these voltages, but they can't cause any more current to flow, and our output stays at 0. So as we've done previously, we can capture this behaviour on a little table. So currently we're at low, and we've got a high output here, which is this line here. If we go low, high, we have a low output there. If we have high, low, get a low output. And if it's high, high, we get a low output there. And this is the table, and this is the table which corresponds to the NOR function we saw earlier on. So with one transistor, we've seen that we can create an inverter. With two transistors in series, we can create the NAND function. With two transistors in parallel, we can create the NOR function, as we do here. Once you start to get more than two transistors, the number of possibilities gets very large very quickly. So we're only going to look at one more. We're going to look at the exclusive OR function. We're going to look at it for two reasons. Firstly, it's very useful for when we look at arithmetic, which is what we will do after that. And secondly, it shows how we can create any function we want by combining connections in series with connections in parallel.